Okay, hi, my Math 40 Plus group. I'm going to be going over one problem from 5.3, one problem from 5.4 to start off today's lecture portion. And then I'm going to be going over what you need from 5.5 and 5.6. Next week, we'll get into Chapter 6 material. If you do have questions during this time, just type them in the chat for now or raise your hand in the participant box, and I will take a break in a couple problems to answer those. So let me clear this out. I'm actually going to start with section 5.3. And this is classroom example 6. We're going to want to verify this particular identity, and in order to do it, we're actually going to see that this relates to the sum, to the cosine sum identity. So first and foremost, go ahead and put a line down the middle here. Okay, so that we know we can't cross over, all right? So the way that I'm gonna show that the left-hand side turns into the right-hand side when we simplify. So the first thing is to note that we have a secant here with some argument behind. Recall, if we had secant theta, that would be 1 over cosine theta. In this case, theta is pi plus x. So the first step is to change this into the reciprocal identity, 1 over cosine of pi plus x. Okay. Common mistake is to write this like this. That actually doesn't make any sense because you don't have an argument for cosine. This argument must be right next to cosine. Okay, now your next step stems from, there we go. Stems from the denominator here. Remember, we learned a song for this last time. Essentially, the song was sine, cosine, cosine, sine, cosine, cosine, sine, sine. So sine, cosine, cosine, sine, cosine, cosine, sine, sine. Essentially, this part here tells us what we're going to be using for the cosine sum and difference formulas. So remember the way to do that, we have cosine, cosine, sine, sine. And then we have our A, B, A, B. What that's equivalent to, okay, if we have a plus here between the A and B, then we're going to have a minus here. So we have cosine pi plus x. We're going to replace A with pi, replace B with x. Okay. You go ahead and clear some of this out. Actually, I'm going to clear the whole bottom. Okay, so the parts that don't change, you're going to have your 1 divide. And then this denominator here is going to be a little bit long. Changes to cosine, cosine, sine, sine. Pi x, plus here, minus here. Okay. Now the next thing is you can simplify some of these values. So cosine of pi, for this part, you want to think, where's pi radians from standard position? It's over here. And that point that would be associated with that value on the unit circle would be -1, 0. So what that tells us is that cosine of pi, the first value here, is -1. And that tells us sine of pi, the second value here, is 0. So don't forget your 1, divide by. We have -1 times cosine x minus 0 times sine x. Remember, anything times 0 is 0. So let's simplify. Go back to pink. We have 1 over -1 times cosine x. That's negative cosine x. Okay, let me see if I can smoothly move this down. Not exactly. Okay, hold up. Okay, there we go. That should be enough room. Okay, so then your final step here, the negative can come out front. And then 1 over cosine x, remember that is secant x. So left-hand side, simplified to right-hand side, and we're done. Okay, so let me go ahead and save a picture of this. There's one problem that I want to cover from 5.4 that might appear in your homework. And that's going to be classroom example 3. See if I can do this smoothly. Yeah, there we go. So this is the problem that we're going to tackle. We might need a little extra room here. Okay, so for this particular problem, it says suppose that A and B are angles in standard position such that cosine of A is given. And then you have bounds for A, and sine B is given, and you have bounds for B. Find each of the following. So what I'm going to show you is that first we're going to find sine A minus B. And then instead of using a tangent formula for this particular part, we're going to find cosine of A minus B as well, and then just make a ratio to find tangent. So let me start by identifying my 2 angles. One's going to be angle A. Okay, so I'll start over here. So for angle A, it's given between pi and 3 pi over 2, which means it's in Q3. And then you have angle B. That's between 3 pi over 2 and 2 pi, which means it's in Q4. Okay, so now what we are going to need to know is the sine difference identity. So sine, cosine, cosine, sine. AB, AB. Remember, there's a negative here. Follows opposite rules for cosine. You're going to have a negative here as well. Okay, so sine, same sign. Okay, so the reason that we need this, we can check off what we have here. For A, we have cosine of A. And that's given as -7/25. And we have sine of B. Which is given as -3/5. Okay. So what does that tell us we still need to find from this particular formula? We need to find sine A and we need to find cosine B. Okay, so that's going to be our first step. For this, the identity that we're going to use for both of these, sine theta, sine squared theta, plus cosine squared theta equals 1. In the first case, theta will be replaced by A. In the second case, theta will be replaced by B. Okay, sorry, I had to check on my cat because she's killing something in the next room, apparently. Okay, so now, let's go ahead and let's move all this up. I see you, there you go. Actually, I'm not gonna have enough room. Let me just do this part in a separate share. So I'll share my whiteboard with you. Okay, so this is for classroom example 3, section 5.4. The first thing that we're going to be doing, we're going to find sine A. And we're going to use this formula to do it. You actually have choices here. You could plug in your values first to find sine A and back solve, but I like to go ahead and just solve this general formula first. I want to isolate sine A. So let's do that. Sine squared A equals 1 minus cosine squared A. Take the square root of both sides. Don't forget your plus minus in front. Okay. Now to choose the sign, we know that angle A is in Q3. Okay, that means that your sine value should be negative. So sine A is equal to negative square root 1 minus cosine squared A in this case. Let's plug in. Sine A equals negative square root 1 minus, recall, cosine of A is -7/25. So we're going to put -7/25 and square it. Okay, and then you can just plug into a calculator if you want to make it a little bit easier for you at this point, but I would suggest practicing simplifying this without. It's going to come out to negative 24 over 25. Now we need to do the same thing for angle B. But now we're looking for cosine B. So cosine squared B equals 1 minus sine squared B. Take square root both sides. Don't forget your plus minus. Remember that angle B is located in Q4. So cosine should be positive in Q4. So we have cosine B equals positive square root 1 minus sine squared B. Let's see if I can smoothly do this. Yep, okay, great. Okay, so then similar, cosine B equals square root 1 minus. Recall that sine of B is equal to negative 3/5. So we're going to take negative 3/5 in parentheses and square it. And then when we simplify that, we wind up getting 4/5. Okay. Let me save a picture of that. If you need a picture of this, go ahead and take it real quick because I'm going to flip over to the last screen to finish this problem out. Oh, that sucks. Got rid of all the stuff I had, but that's okay. All right, so here, remember for part A, we have sine A minus B, sine, cosine, cosine, sine, A, B, A, B, sine, same sign. So we fill in what we had. Sine A, negative 24 over 25. Cosine of B was 4/5. Cosine of A, negative 7/25. And sine of B, negative 3/5. So practice with that as well, algebraically simplifying without a calculator, just so you have an idea, but you can use a calculator for it. This comes out to negative 117 over 125. So that's part A. Okay, let me move this stuff up. Okay, so we have part A done. Next is part B. Tangent A minus B, remember we discussed these formulas last time. You can use the tangent formulas if you want to. B tan, 1, tan, A, B, and then same sign on top, opposite sign on bottom. It's not that bad. You'd have to just find all the tangents individually, but I like to teach this using the quotient function for tangent here. So let me go ahead and erase that. Instead, I'm going to use sine A minus B divided by cosine A minus B. That way you only need to remember the one song, okay? We already have sine A minus B, so now we have to find cosine A minus B. And remember cosine A minus B, sine, cosine, cosine, sine, cosine, cosine, sine, sine. A, B, opposite sign between. So we still have all these values. So let's just replace here. Cosine of A, that was -7/25. So I don't have to change color as much. Sine A is -24/25. And then cosine B, that was 4/5. And sine B, -3/5. So what we find from this is that cosine of A minus B comes out to 44/125. Okay, so we're gonna need this for this portion. I shouldn't box that. All right, so let's find tangent A minus B now. That's going to be -117/125 divided by 44/125. Remember the trick, same number in the denominators of the complex fraction, they cancel. So we get -117/44. Let me erase this part too. So this is part B. All right, so we have part B down, and then the last part, finding the quadrant. Let's do another color. Of A minus B. Essentially, you want to look at the signs of your sine and cosine values here. So remember, sine A minus B, it's negative. And cosine A minus B is positive. These are the quadrants when sine is negative. These are the quadrants when cosine is positive. The overlap happens right here in Q4. Okay. All right, so let me pause for a moment and then see if you guys have any questions before I move on to 5.5. All right, you guys, so we're moving into 5.5 now. I'm going to go over a few of the problems that I think would be useful for you, and then let you know the parts that you don't really need to worry about right now. Okay, so basically, let's start by filling in this chart here. And actually, no, let's not fill this in yet. We're going to show a little bit of detail here first. The next bit is double angle identities, and in 5.6, we're going to cover half angle identities. So where that comes from, notice that the first equation we're going to have has cosine 2a. Essentially, that 2a is in the argument of cosine. So we're actually going to show that we can derive these formulas using Pythagorean identities. And sum difference formulas for sine and cosine. Okay, so to derive, you'll need those. So essentially, the way that we want to think about this, how can I break up 2a into two terms that are added or subtracted? Well, 2a is a plus a. And then remember, we have a sum identity for cosine. Cosine, cosine, sine, sine. Now we're going to have A, and A. And then we see a plus sign here, so we're going to want a minus sign between. Now this part's just algebra. Cosine A times cosine A, what would that simplify to? Cosine squared A minus sine squared A. And this becomes our first formula. Okay. Now let's show that we can continue to manipulate this. So cosine of 2a is equal to cosine squared a minus sine squared a. So let's use a Pythagorean identity here. Okay, what I'm going to do, I'm going to change sine squared a to the quantity 1 minus cosine squared a. Okay, so that's a Pythagorean identity moved around. Now, what do we get from here by algebraic simplification? Well, cosine squared a minus 1 from distribution plus cosine squared a from distribution. Like terms, that's 2 cosine squared a minus 1. That's where our second formula comes from. And finally, let's start again from the first formula that we derived here in this section. Now I'm going to use another Pythagorean identity here. I'm going to change cosine squared a into the quantity 1 minus sine squared a. Then be careful here, you don't have a distribution because you can essentially just drop the first parentheses, keep the subtraction. like terms. So we have 1 minus 2 sine squared A. And those are the 3 double angle identities for cosine. Okay. You save a picture of that, and I guess I'll just try to do all this on one page first. So next, we're going to look at the sine double angle identity. So for this one, you're going to use that same premise to start. You have a sum formula for sine. Okay, so that part is sine, cosine, cosine, sine. A, sine, same sign between. Now notice you could rewrite this as sine A cosine A plus sine A cosine A, just flipping the terms here. Since it's multiplication, you can do that. So these are like terms. We have 2 of these sine A cosine A's. So that gives us our sine double angle formula. And then tangent, typically you'll just want to use a ratio. So remember, one way you can do this is just sine 2a over cosine 2a. But the formal equation that your book gives you is 2 tangent a, or 1 minus tangent squared a. Okay. Let me save that picture. If you need it, go ahead and take a picture of it now. I'm going to clear out everything but the formulas. And we are going to go into the second problem. Actually, we can do the first problem. That's fine. Okay. So let me clear everything over here. Sorry, it's going to take me a minute since I have not figured out how to delete everything but a certain section. All right, perfect. So we have 1, 2, 3, 4, 5, 6 different formulas that we can use. All right, so we'll do classroom example 1. You're given sine theta and the quadrant for cosine theta. You want to find the double angle formulas though. So sine 2 theta, cosine 2 theta, and tangent 2 theta. So first thing is to figure out which quadrants we're talking about here for theta. And actually, before we talk about that, let me step back a little bit here. The reason why I'm going about that, think about your general formulas first. So I'm looking for sine 2 theta. And I know that the formula is 2 sine theta cosine theta. Okay. So I have sine theta already, but I'm missing cosine theta. For cosine 2 theta, we have options here. Since you actually have a formula that only depends on sine, you could use this formula. it won't matter which one you use. They should all come out the same. And we actually have that already, so we can find cosine 2 theta. And then tangent 2 theta, don't use a new special formula for this, just use the ratio of the last 2 items you find. Okay, so both of these we don't know yet. Okay, so let's start with sine 2 theta. We're going to need to find cosine theta first. We know that it's negative. So cosine theta is negative in either Q2 or Q3. The way that we figure this out, sine theta is positive. So the only place that that works is Q2. Okay, so now we're going to use a Pythagorean identity here. We're looking for cosine theta. So cosine squared theta equals 1 minus sine squared theta. Square root both sides, don't forget your plus minus. And then we're told that it's going to be negative for cosine theta. So cosine theta equals negative square root 1 minus 8 over 17 squared. So when you plug all that in and simplify down, you get negative 15 over 17. So now we're ready to find sine 2 theta. Should be 2 times sine of theta, which is 8 over 17, times cosine theta, which is negative 15 over 17. That comes out to negative 240 over 289. All right, give me a second. I'm gonna pause real quick. All right, you guys, so we went over the first portion of classroom example 1. Let's go over the last 2 parts here. Okay, clear this out. Bye. Okay, so now we're looking for cosine 2 theta. And we have a formula for that. So go ahead and replace sine theta with 8 over 17 and then square it. And that comes out to 161 over 289. Now you already have sine 2 theta and cosine 2 theta. So again, you don't need to worry about these bits here. Sorry, this one here. Just use this formula. So we get negative 240 over 289 divided by 161 over 289. So this equals negative 240 over 161. Okay, so we finished classroom example 1. Let me do one more problem before I take a break to see if you guys need any more assistance. I'm going to go ahead and clear all this out and go to the next page. So I'm actually going to be covering 2 problems, but I'll just start with this first one, classroom example 3 here, to show you some of the identity problems. Okay, that's not what I want to do. Go ahead and draw a straight line down here. And we're trying to verify the following identity. It's cosine to the 4th beta. So this symbol here is a beta, lowercase Greek letter. Cosine to the 4th beta minus sine to the 4th beta equals cosine 2 beta. So we're going to show that the left side and right side simplified to a third expression. So working both sides of this particular problem. Okay, so the first thing, remember I have 3 different formulas for cosine 2 beta. So I'm going to want to start on the left-hand side here, just so I can factor first and then try to get to the correct form of cosine 2 beta without having to do too much. So this is actually a difference of square. On the left-hand side, you have cosine to the 4th beta minus sine to the 4th beta. Remember, a squared minus b squared turns into a plus b, a minus b. So what are we squaring in both these cases? Well, we're taking cosine squared beta and squaring it. And we're taking sine squared beta and squaring it. So our 2 factors should be cosine squared beta plus sine squared beta and cosine squared beta minus sine squared beta. Okay, so the first thing we're going to do, we're going to put this bit over here. That is too big. All right, I'm going to rewrite it over there. Okay. Now let me go ahead and select this too. Just new. There we go. Okay. Now the next thing is, can you simplify either of these? Well, actually you can simplify both of them. What we get here, what is going on with this? What we get here, this is a Pythagorean identity. And it just equals 1. Okay. And then over here, we have another difference of square. So cosine squared beta minus sine squared beta, that's cosine beta, the quantity squared, minus sine beta, the quantity squared. Your 2 factors will be cosine beta plus sine beta. And cosine beta minus sine beta. And actually looking at this, I realized I don't need to do this. Okay, the hint for that, let's go ahead and rewrite this. Okay, when you take 1 and multiply it to this factor, you just get the factor itself, right? Ah, this is what cosine 2 beta is equivalent to. Okay, so that would actually be enough to stop right there. Another option, if I didn't want to write this part in, I could have just said, oh yeah, I know that this is cosine 2 beta, and I showed left side equals right side. Okay. All right, let me save this and then let me go ahead and pause